Oh, we are good to go, Bhaiya.
All right. All right. So, a very good morning to one and all present here. I welcome you all to the 12th edition of Amalthea. Amalthea is the annual technical summit of IIT Gandhinagar. It is India's first student run technical summit and the largest technical summit of Gujarat. Amalthea's theme this year is unifying minds and fostering ingenuity. Since no event can be organized without the proper support of sponsors, hence I would like to give a thank you to GSW, our title sponsor, Hindalco, our associate sponsor, and for their valuable support. Amalthea aims to provide a platform and inspire young minds to ponder upon existing problems and find innovative solutions. Today, we are grateful to have with us Dr. Kirk Borne, someone who has always tried to find unique solutions to real world problems. Today, we have with us a very active personality in all things data science, artificial intelligence, and machine learning. Dr. Kurt Bonds holds a bachelor's degree in physics from Louisiana State University and a PhD in astronomy from one of the best at Caltech. He is a global influencer, a speaker, a writer who has started as an astrophysicist. Dr. Kirk Bourne, in more than 30 years of his experience, has worked as a space scientist at NASA, a researcher at George Mason University, have worked as a consultant, a data scientist, and currently he is the chief science officer at dataprime.io. In short, he is someone you would want to give all his attention to in today's webinar. So let's gear up to witness something very insightful ahead of us. Now, after this short introduction, I'm sure we would all be very delighted to know more about you, sir, which we might not find on your LinkedIn.
All right. Well, thank you very much. I'm very pleased to be here today. I hope you can all see my slides. So we're starting at this wonderful event. So you asked a very good question to start, like what do you know something about me that you wouldn't find on my LinkedIn? Well, I'll tell you. I'll tell you something special. You did mention I have a PhD from Caltech, and in the academic world, there's a thing called the mathematical genealogy, where you basically can list all the people that you have directed as PhDs, like me, and then people who directed me. And so the guy who directed my PhD is I call my academic father. The guy who directed that guy's dissertation PhD is my academic grandfather. And the guy who directed that person's PhD is my academic great grandfather. So my academic great grandfather, who advised the guy who advised my advisor, was none other than Subramanian Chandrasekhar, probably one of the greatest astrophysicists of the 20th century from India, University of Chicago, where he spent his career. But my academic great-grandfather is Subramanian Chandrasekhar, and I'm always honored to have that connection with India. And two of my PhD students, so I'm their academic father. Two of my students are from India, And so when I told them this story one day, we all shared tears in our eyes with this connection that we have to one of the greatest astrophysicists of the last century. And so this is a great opportunity for me to just reconnect with the way I feel very strongly connected to people in your country. And I have visited Bangalore. I went to Data Hack 2017. So I had wonderful experience with people and food and data science. So today we're going to talk about data and AI and how data and AI are reshaping our world. So I do work at Data Prime. So Data Prime is a startup. So we have very few people, but we help people find jobs. Okay, so we don't offer jobs, but we try to use AI and machine learning to match people's skills to specific jobs. And so what we do is we interact with recruiters at large companies who are trying to find the right people to match the job that they have. And so we encourage people like you on the phone, or you here out in the world today on the webinar in this summit. If you have an interest in any kind of data job, like data engineering, databases, data mining, data science, AI, machine learning, even data ops and DevOps, software engineering around cloud analytics, any job like that at all, you can upload your profile, just description of who you are, what your skills are, what your interests are, what your education is. And you're not applying for a job. You can just put your profile there, and someday, maybe in the future, not too far, some company will say, yeah, this is the person we want. All right, so feel free to go to dataprime.ai and upload your profile. It doesn't cost anything. And again, you're not applying for a job yet. I mean, it's just a place for you to be in the database when some company comes looking for someone exactly like you. And so we use AI and machine learning to do that matching, to match the perfect job to the perfect person. So if you are the perfect person, you better be there. Okay, so how is data and AI reshaping our world? Well, first of all, let's just start with the obvious statement that AI, artificial intelligence, devours data. Some people say it consumes data. Well, there's a difference between consumption and devouring, right? So I consume breakfast, okay? But when it's my favorite breakfast, I eat a lot of it, so I devour it. So AI devours lots of data. And so I like to call AI not artificial, but other things like actionable intelligence, actionable insights. And it comes from many different data sources. In the same way that a human intelligence, a real live human intelligence, devours data. That is, we have eyes and ears, and we taste and we touch and we feel. So we hear and see and touch and taste things, and those are our sensory inputs. That's the data that enables us to make decisions and take good actions in our life. And AI is like that. It takes data from many different sources and sensors to take good actions. So AI devours data. And what it's doing is it's finding patterns in data, which we call insights. Now, what do I mean by insights? Well, first of all, let's talk about a couple other phrases here: machine learning and data science. Sometimes people confuse these two things in the sentence and refer to them as the same thing. But I like to say machine learning is just the mathematics, right? So it's the mathematics of finding patterns in data, finding patterns in numbers, right? So machine learning is mathematics. It finds patterns. And what kind of patterns? Maybe groups and clusters. That's one type of insight and pattern we list here. Another type of pattern is a correlation between different numbers. So correlations, that's a pattern. Machine learning algorithms can find those things. They can also find outliers, which we like to call surprises. So my two PhD students from India actually both worked on this particular type of research: surprise discovery in data. How do you apply algorithms to find interesting, surprising, unexpected things in your data? And another pattern is links and associations, called graph mining or network science. For example, finding the relationships between people, or relationships between articles, or even between web pages. So even a search engine uses link analysis to find the most authoritative node in the network. So mathematics, called machine learning, helps us to find patterns. And data science is the scientific method applied to data. It's the scientific method applied to insights discovery. So when you find a pattern, how do you know what's meaningful? And if you want to use it again to predict that pattern again in the future, how do you build an accurate model to do that prediction? So that's a scientific process where you test the algorithm, you iterate with the algorithm, you change the parameters, you tune the mathematics to get the most accurate possible model. That's a scientific process. So data science is the scientific process of applying this mathematics called machine learning, pattern recognition, pattern detection, to insights discovery. And what happens with insights discovery is it enables us to make decisions and take actions. And that's what AI is all about. So AI is very data-driven. So data-driven and machine learning applications, AI applications, are everywhere in our life. So they're predicting things and optimizing things and discovering things and detecting things. So like, for example, predicting what product you might want to buy, predicting your credit score, or even a smartphone autocomplete. Has anyone ever had a funny problem with their smartphone autocomplete? You're typing a message to someone and it types the wrong word. Okay, so it's not perfect. Okay, and that's like all of our algorithms. A famous statistician once said that all models are wrong, but some are useful. And so we have to think about that. We're just fitting a curve, so to speak, to data points. The curve is not the real world. The model is a representation of the real world, and sometimes the representation is not perfect. Okay, so keep that in mind, that the real world, we measure things in the world through data, and we try to understand it through these pattern matching and algorithm fitting techniques. So here's things that we can predict. We also can optimize. For example, if you have a map, like a traffic map on your phone, you can optimize to get to your destination, whether it's in a car or a train or whatever it might be. You can optimize how you get to your destination. We can optimize your learning or optimize your schedule. You also can discover things. For example, discover health issues or discover your best deal online, or even detect things like for example, identity theft or credit card fraud, or even detect what your social sentiment is. Anybody out there on Twitter? Anybody? Okay, well, I'm on Twitter. I got a few followers out there. So excuse me. So you can detect, the algorithms can detect, are you feeling happy or sad? Did you like this talk? Did you not like this talk? I mean, so set social sentiments. So all these things are applied in our daily lives. But these exact same techniques or categories of pattern discovery applies in business as well. So we see in business also predict, optimize, discover, and detect. So for example, predicting outcomes, events, prices, and costs, product demand. We can also optimize our processes, or I like to say product, services, supplies, and people. We can discover insights about what's happening in our market, what's happening with our customers, what's happening with our products. We also can detect fraud and detect, for example, safety events or behaviors, for example, cybersecurity breaches. We also can detect inappropriate uses of data. So the general data privacy regulations determine how people should use your data, right? We all see these data privacy statements, and they're very serious. And so companies can use AI to detect inappropriate uses of data. So businesses are using this stuff everywhere to create new opportunities and to keep their business efficient and effective. So here's an eye chart. Oh my gosh, don't try to read all this. So here's 5 AI technologies driving business value. Image recognition, speech recognition, chatbots, natural language generation, which is basically conversational AI, and sentiment analysis, which I was just referring to. But I found something very interesting when I looked at this. I felt like this is an interesting and complete list of things under those categories, but they're missing something. And they also sort of miss something else, because really the first one is different from the other 4. So what are they missing and what's wrong with this chart? Well, here's how I like to categorize it. I say there's really 3 broad categories. Image understanding. That was the first thing on that other chart, image understanding. The second one captures all 4 of the other things on that chart, language understanding. And the one that was missing is context understanding. So I like to say that AI's outcomes are not artificial. Like I said earlier, I like to call AI not artificial intelligence, but actionable, okay, accelerated, amplified, assisted intelligence. It's because it's all about action. It's all about doing something with the data and accelerating and improving outcomes. So AI, yes, it consumes data, but it takes that data to insights, those insights and patterns we were just talking about. And from there, we take action. We make decisions to take action. And hopefully those actions bring value both to our lives and our businesses. So let's talk briefly about these 3 broad categories, and then I'm going to give you a whole bunch of different applications of this stuff in our world, and then we'll see how that wraps up. So let's begin with just a short summary of each of these three, and then we'll get into some more details about the applications. So here's some examples of image understanding. For example, image and content labeling. For example, if you upload a video on YouTube, in the past, if you would upload a video to a website, you could put some keywords there. You can write a description, you can give it a title, but there could be a lot more things in that video that you couldn't put in the description because maybe it's 30 minutes or an hour. And so AI can automatically label the content in the video. It can find the things that are in the video and label the video with that content. For example, you might be at a sporting event and it's maybe a World Cup soccer game, World Cup football game, excuse me. So we have these, but in the video there might be something special, like a special player or a special action that happens in the game, and you can search. If it's labeled properly, you can search it. So image understanding helps us to understand the content both in images and in video, to tag it, to curate those tags so we can now search it. But if it's doing that, it can also automatically create a caption, just a short description of the image in the video. Of course, the biggest example we know in our lives, there's autonomous vehicles. All right, so autonomous vehicles have cameras and radars and lidars to understand what's in its environment so that this vehicle can drive safely in the environment. And there's another example called facial recognition. And sometimes facial recognition is talked about in the context of maybe law enforcement or some kind of a policing type of action or something that's invasive of our privacy. But there's another very simple, powerful example of it that we use every day. At least I use it every day. And that is I unlock my smartphone with my face. Right? I don't have to type in the code. It just recognizes my face. Okay, so that's a very convenient type of facial recognition. My face is my password. Okay, so it's using the biometrics of my face through AI to unlock my phone. So these are all examples of image understanding. Language understanding, as we said before, there's many different categories. Like that previous chart, they had 4 different categories. So there's both natural language understanding, that is, what is the word saying? There's also natural language generation, that is actually creating a conversation. Okay, so it can generate words. So you can have a conversation with the AI, with the bot, the chat bot. It also does sentiment detection and analysis, as we mentioned, but it also can do emotion detection. So yes, you might have a sentiment like, I really like this or I really dislike this, but what's my emotion? Am I angry about it? Am I happy about it? Or do I have no emotion? I mean, those are important things. And all that stuff is being used in, for example, contact call centers. The contact call centers are now using AI to help detect the sentiment and emotion of the caller. And also, not only that, but what are they talking about? What are the questions they have, and it helps to answer the questions. So what language understanding also can do is this content discovery. So what is the topic? All right, can I tag the topic now so I can search it? Or can I summarize it in some kind of simple way? So when the call center person finally gets on the phone to talk with you while you were conversing with the bot, they already know what it is you're asking about. What kind of information are you seeking? Are you angry or happy about it? Or are you concerned about something? So it also can identify entities. For example, I said, I want to know my account number. So it can easily pull up the account number because it understands those words. But you can also get to identify entities inside of documents, and find places and people and things in documents just by searching through the document and realizing, oh, this is a person or this is a number. And when it identifies that this thing in the document is a number, it can actually extract the numerical quantity and put it into a searchable database. So the reason this is important, because over 80% of the data in the world is unstructured data. That is, it's not organized in nice rows and columns in a database, right? Only a small part of the data in the world is organized in small rows and columns like that. Over 80% of the data is unstructured, and that includes images and video and texts and documents and web pages and and chat rooms and social networks. It's all mostly unstructured data. And so this is very powerful and extremely, maybe one of those important aspects of AI is language understanding. But if we're ever going to get really what we call artificial general intelligence, that is, it does more than just one thing. If the AI does more than just one thing, for example, recognize a dog in an image or recognize an account number in a chat, it's going to need more sensors, so to speak. And those sensors give context understanding, like what else is going on at the same time as this event or behavior? What else is going on at the same location as this event or behavior? And what else is like this in data parameter space? So an example of that one would be, for example, a product recommender engine. If you go to an e-commerce store and it recommends a product to you, people who bought this book also liked this book. Well, it's not about they like this book right this very minute. They could have liked this book 2 years ago. And it's not that they like the same book at me in this particular school. Maybe they're in a completely different school. So other data in your data parameter space. So context, as a scientist, as an astrophysicist, I like to say this is the space-time continuum of data. All right, it's the full hyperdimensional. We think about our universe as hyperdimensional. Some people like to think we live in an 11-dimensional universe. That's called string theory. Then other people think there are multiple universes that all live in parallel. I don't know about that. That's not a provable hypothesis, but it's an interesting one. So all these extra dimensions besides space and time are very powerful. And our data has all those extra dimensions. They have all this information about where you live, what you like to buy, what are your interests, what are your preferences, what are your skills, where did you go to school, or even in businesses. You have a machine operating or an engine operating in a manufacturing plant. Well, what's the temperature of the plant? How long has the machine been operating? How many other machines are around it causing vibrations that might cause this machine to malfunction? So all this contextual information makes you smarter, makes our AI smarter. So we need to include context understanding. And one way to bring context into a data discussion, into an analytics application, is through something very powerful called knowledge graphs. So if you go back to my slide, which I won't do right now, where I had the 4 types of insights discovery patterns, we had clusters, we had correlations, we had outliers or surprises, anomalies. And the 4th one was link discovery, using graph analytics, finding the associations and links between things. And that's a perfect way to actually store contextual information about your data. So now you can find things, well, this happened, look what happened, look what else was happening at the same time, same place, or in feature space very similar to this thing. You can do that very straightforwardly with a knowledge graph. And there's lots of graph databases now available, and graph machine learning is becoming a very powerful algorithm. Because I like to say the natural data structure of the world is not rows and columns, right? We're used to Excel spreadsheets and databases. That's not the natural structure of the world. The natural structure is things, entities, and relationships, right? It's about you and me. It's about our relationship. It's who you're related to and who I'm related to. So you know me now, and you know through 3 degrees of separation now, you know Subramanian Chandrasekhar. You're connected through me, 3 degrees of separation. So put that on your resume. Okay. So it's all about those links and associations that bring power to our data, because what it's really doing is bringing context. And as far as those 3 categories of AI, I think between language understanding and image understanding, the absolutely most important one is context understanding. So we live in this world where there's just rapidly expanding frontier of emerging technologies. Okay, here's another eye chart. Don't try to read all the words there. But we see AI and 5G and robotics and drones and deep learning, virtual assistants, machine learning, virtual reality, augmented reality, and oh my gosh, Metaverse. It's been talked about nonstop this past month. Okay, natural language processing, and the list goes on. Blockchains, digital twins, quantum computing, many different things here. And the thing I want you to take away from this is not all these words, but at the top, what I'm saying here is all these innovations, this expanding frontier of emerging technologies, almost all of these are inspired by data. They're informed by data. They're enabled by data, and they help create value and jobs from data. So that's a pretty powerful application of data in our lives. But it's also a pretty powerful application of AI, because AI is actually driving this edge forward. It's actually driving innovation in the world. It's accelerating and amplifying and assisting and augmenting all of these things you see here. That's why AI is not just artificial, it's all these other kinds of things. Augmented intelligence, actionable intelligence, assisted. So AI is driving this edge. So I want to spend some rest of my time talking about a few of these on this slide here. Not all of them, it would take forever. So I'm going to talk about a few of these. And I'm going to start with AI, of course. So we'll talk about that. And then we'll talk about robotics and drones, autonomous vehicles, and all these different realities, augmented virtual realities, metaverse realities. Then I want to talk about the Internet of Things, because that to me is sort of the capstone there. That's the Internet of Context. All those sensors that we're putting on the world, which we call Internet of Things, those sensors are those other eyes, the other ears, so to speak, that are capturing all the context. So sensors can capture other information about what's going on around your car, or around your life, or around that sporting event, or around that machine or jet engine. That context information comes from other sensors. That's that space-time continuum of data. And then we'll get to some really big global issues, climate and sustainability, and how AI can drive us in positive directions in that area. Here we go, AI. So we already been talking about AI, but I just like to just give, for each one of the things that I just mentioned on the previous slide, I'm going to go through a slide that looks like this one. So it's going to tell you what the topic is, AI in this case, and it's going to list some specific examples. So when you walk away from this talk today, I hope you can walk away with 30 or 40 or 50 or 60 different examples of how AI is impacting our world. So when your friends and family say, well, what did you learn this week? Well, hopefully you can say, and they say, well, what's AI? Is it all about robots taking over the world? Robots killing people? And I say, no, stop for a minute. I learned at least 50 different applications of how it's benefiting our world in some special ways. So AI, some examples. I mean, we encounter these every day. So some of these things are not, they're not like rocket science here, though yes, we are applying AI to rocket science too. But from my years at NASA, we started doing that, and now I'm going back and consulting with a group at NASA who's using AI to actually find other planets around other stars. And who knows, maybe we'll find another Earth someday. Okay, what's an example? For example, digit detection. So you think about when you send posts through the mail, postal code readers have to identify the digits to know where to send the letter, right? How to route the letter. And it needs to do that billions of times per day. So no human being could do that, right? No team of human beings could do that. And so what it's actually doing is it's recognizing the numbers, that the postal code, numbers and letters, of course, to recognize the postal code to know how to route the letter automatically. And believe it or not, that is actually computer vision. That's an example of image understanding, because something written on a piece of paper, it's a number, but it has to recognize the pattern in the number, so that's image understanding. That's an example of computer vision. There's another example we see every single day or encounter every day, and that's email spam detection. It's also used in very serious applications like disease detection. Disease detection uses computer vision quite a bit in the medical imaging. So, for example, if you have a spot on your lung, is that spot cancer, or is it just a bruise? Maybe you just bumped yourself. Maybe it's inflammation. For example, you have some kind of a virus or something, and just simple treatment will take care of it. Okay, so it could be any number of things. It's the pattern of that bruise, the pattern of that spot. Is it smooth? Is it rough? Does it have high texture? Does it have smooth edges, rounded edges? What's the coloring of it? So all these different concepts of texture and smoothness and color and gradients, all kinds of mathematical things, right? What's the gradient? What's the variance or the dispersion and the values across that spot? Is it just a smooth red spot, or is it very rough? If it's very rough, it's possibly cancer. All right, so those mathematical concepts come into play in these machine learning and deep learning algorithms in disease detection. But it's also, the AI is used also in a lot of other ways, like location intelligence, understanding if you were at this location, what else is going on there? Or just the fact you're walking down the street and there's maybe a shop of some particular special kind of food that you like, and that shop has a special, and it recognizes, hey, Kirk Borne is walking down the street, and Kirk Borne likes pizza. And there's a pizza shop around the corner, Kirk. Hey, so an app pops up on my phone offering me a coupon, 10% off pizza if I just go around the corner to this shop. Okay, location intelligence. That's very powerful, actually, in business and supply chain, logistics, everywhere. We've also mentioned chat bots already. Conversational AI, very common example in our lives. Online product recommendations, fraud alerts of all kinds, cyber security, financial benefits applications, and anomaly detection and all kinds of things, people, processes, machines, devices. So AI everywhere. So it's going up to the top line now. So it's the application, AI is the application of mathematics, which we get correct, we optimize using the data science technique, that is data science as a scientific method, in order to inform and decisions and to initiate actions. That's really what AI is all about. It's that actionable intelligence. So an example of that is a robot. Okay, so a robot can be something that's just repetitious. So it's not, there's no AI in a robot that just keeps doing the same thing repeatedly, like, like hammer something. If it just keeps pounding, something comes down the assembly line and it just keeps repeating the same thing. But what if that thing that comes down the assembly line is in a different position? Okay, so you need some kind of computer vision to say, oh, I need to hit it over here or over here. Okay, so now robotics are getting some intelligence built in through computer vision or other techniques to actually be more intelligent in what it's doing. So it's not just a repetitive process, it's an intelligent repetitive process. So robots are devices that move and react in response to sensory input. Hey, just like us. Okay, so robots move and react and take actions from sensors just like us. We have eyes and ears and we have our sensors. Robots are doing this in many different environments, as suggested in the slide here with the examples I mentioned. And there's pictures in the slide represent each one of those examples. But the one I think is most fun is the number 5 there, which is autonomous exploration, deep space, like on Mars or deep in the ocean, or even remote environments. I mean, I've heard an example of, for example, when there's really serious things happening in the world, whether it's conflicts between peoples, or if it's a fire or a disaster like a hurricane or a flood, a tsunami or something of that sort, you can actually send drone robots, journalists as robots, not real journalists, but a robot that could fly in. So what a drone is nothing more than a flying robot. Okay, so you can send robotic journalists, AI journalists, to those very dangerous areas without having to send a human there, and they can do reporting. And in fact, it probably can do a better job of reporting because you're going to put all kinds of different sensors on their cameras and sight and sound, and multiple sensors looking in multiple directions. And so it's pretty an interesting application of AI in the world. So again, drones are an example of a flying robot. So it could be not a robot AI in some sense. It could be a drone that has a predetermined flight plan. So it just goes and does the thing that is pre-programmed to do. So that's not really an AI. You can be controlled by a human. So if you have a control panel, you can fly the robot around. Okay, so it's not really an AI. It's under your control. But there's also drones which are totally autonomous. That is, when they fly into a disaster zone, for example, a fire situation, it can identify the hot spots, or a flood situation. It can identify in the flood if there are people who need rescuing. It can identify persons and people and things that need rescuing in a disaster situation. So that's more of an autonomous, intelligent drone. And so there's many applications of drones in business, in construction, in disaster response, and sort of traffic management in cities, development management in communities, and so forth. But also fun applications in our toys and our games. So a more exotic example of a robot, if you will, is a self-driving car, because in a sense that's what it is, right? So it's making intelligent decisions based upon the data that it gets from all of its sensors. So it has cameras to see what's there. It has radars to get a bigger sense of what everything in the environment, that sort of contextual information. It also has LiDAR. So LiDAR is like a laser radar. Okay, it is a laser radar. So it basically does ranging. Okay, it can say, okay, I see a car, but how far away is the car? I see a person, how far away is the person? I see the car moving or a person moving. Or if I have a car in front of me, if the car is moving at the same speed as me in the same direction as me, that's okay, right? If I'm just following behind the car, that's okay. But if that car suddenly stops, it's important to know that it stopped, all right? Or if a person is walking alongside the road, that should be okay as long as you're not driving on the sidewalk. Okay, so please don't drive on the sidewalk. Okay, so all kinds of actions are initiated or not initiated. That is, the car can be passively driving if everything is safe. So many different sensors and algorithms come into play. So this is probably the most sort of complex robot we're building now, because it actually can affect people's lives very seriously. If there's an accident, obviously lives are in danger. So this could be maybe one of the more complex robots we encounter in our daily lives here, and that's an autonomous vehicle. So now let's enter into the other worlds of other realities. Okay, so the simplest one is augmented reality, where you're just superimposing knowledge or information on top of your view of the world. Okay, so you're not leaving the real world, so to speak. Like if you're in a virtual reality environment, a virtual room or a metaverse, I mean, you're sort of in this alternate world, so to speak. But augmented reality is you're still in your world, and information is augmented or sort of applied to your world. So how do you do that? Well, you can do that with, for example, on your phone or in a mirror, for example, as we see in these examples. So look at the example in the bottom left. Okay, so the person walks in the store and they hold up their phone. This person is still inside the store. This person still sees their store. They're not in a virtual world, but they can hold up their phone, and if they has the right kind of app on their phone for that particular store, it can identify where different products are, like if I'm looking for a particular product, but it also can tell me what things are on sale. I have special prices this week. So that's augmented reality. It's helping me navigate that space, making decisions, maybe purchase decisions, retail decisions. The middle image in the middle panel at the bottom there is a rescue mission in a flooded zone. So if people report, for example, down electrical power lines, that's important to know that you don't want to be driving your rescue boat, right over some electrical power line. Okay, so people can report that there's electrical power outages. That it's good to know that, and certainly you don't want to be in a virtual world. You want to be in the real world, navigating safely this flood situation. But also at the same time, if people can report, other people report, for example, that I see someone needs rescuing. They're on the top of their house, right? There's flood waters all around their house. They need rescuing. So again, this augmented reality can assist a rescue team, whether they're flying in or boating in, to identify the location. And so again, they pinpoints the location, by using this augmented reality. And another example, which I find really interesting, is the bottom right, where the person goes to the store. She's trying on different clothes, but she's actually not trying the clothes on. She's not actually changing her clothes and trying on the new clothes. She actually has this augmented reality mirror in front of her. And as she selects the clothes, she just pushes a few buttons and she can see herself in the mirror as if she was wearing those clothes. So she can try on the clothes without actually trying them on. So that's an impressive example of augmented reality in a retail situation. But also there's all kinds of other applications, which I didn't mention in the photos here, like for augmented medical procedures. Another example of a disaster response situation where a medical procedure needs to be performed on a person, and maybe the procedure is such a rare procedure that the person who's performing it needs some kind of assistance. And so they can bring up a description, even a visual description displayed in front of their eyes if they have, for example, the AR glasses on, some kind of augmented reality glasses on. They can see the instructions. They can see what to do without removing their hands from the actual work that they're doing. They don't need to open a book or open their phone and go find a web page. Okay, they can interact directly if they have the AR glasses on. And so they still need to remain in their real world environment. They still need to see the person they're operating on, obviously. But they can also get all the information they need. For example, the AR could say, go here, do this. And then another example I see is in major machine monitoring and major machine maintenance. For example, wind farms, massive, huge wind farms have these huge wind energy generators. I mean, they're enormous, like 300, 200 meters high sometimes. And so a person doing a repair gets in that environment, and they have to keep their hands free to do the repair, and they can see projected through their AR glasses, AR lenses, exactly which device to push, which wire to undo, what thing to adjust, and so forth. And so it's in predictive maintenance and medical procedures, all these different types of applications, but also there's plenty more I could go into in terms of gaming, security, for example, identifying people at risk in an entertainment or sporting event. Maybe there's 1,000, 10,000, 100,000 people at an event. And AI can detect, for example, if someone is in distress, maybe they're having a heart attack or a stroke or something's happening to them. The AI can do facial recognition software and detect, here's a person who needs attention. All right. And so it's almost impossible for the security personnel to watch every single person when there's 100,000 people. But the AI can watch and help in those situations. All kinds of applications. I mean, it's just a tremendous number of applications. And then we move to the virtual world. So, okay, now you're actually in the world, in that virtual world. And what people don't realize about how much virtual reality is data driven. It's both data collecting and data generation. Sometimes people don't think about that because, first of all, it's collecting data. So as you walk through the world there, okay, it sees where you are. So it's collecting information. What are you looking at? Where are you going? Like if you walk into another room in this virtual world, it has to recognize that, so to change the scene for you, right? So it's collecting data about, and if you're pointing at something or touching something, it has to understand that. So it's also data generators, right? So as you touch something, you want it to react, right? If you want to flip a switch to turn something on in your virtual room, it has to like say, oh, it recognizes what you just did. That's generating data to inform the VR world that you just did something. All right. But a more impressive example is haptics. Okay, so haptics are actually sensors that give you the sense of feeling something. So there are haptics now. For example, I actually saw a video of this just 2 weeks ago. This guy was in this virtual world and they had simulated rain. It was raining in this virtual world, and he felt raindrops on his skin because he had the haptic suit on. Okay, so it understood that rain, and as he was walking through the rain, he could feel it. Okay, so it knew he was walking, it knew he was in a rain situation, and it communicated to the virtual reality software, this person needs to feel the experience of moisture on his skin. And so it generated that sensation in the haptic suit that he was wearing. Just incredible, right? So virtual reality is everywhere. Games and family adventures, training and education, enormous applications in training, certainly in medical training and military training, logistics, how to load a train, how to load an airplane safely. I actually participated in an example. I wasn't being trained, but I participated in an example of a training exercise for the military loading these very large airplanes with cargo. And they have to get it balanced just right, obviously, for the plane to fly safely, right? And so they learn how to do this in a virtual reality environment. They don't learn by loading up a real plane and discover that it crashes after they take off. That's not a good thing. Okay, so I was in this virtual reality plane helping the people load the plane. Then the plane took off. We were flying in this virtual reality cargo plane, and then, oh my gosh, the guy I was with, again, virtual world, he goes to the side and opens the door of the plane. He literally opens the door. I see the engines. I see the wing of the airplane. I see I see everything like I'm really on an airplane. So I see the engines, and there's a fighter jet who's our wingman, basically, that's following along with us. Again, virtual, not real. There's the jet. I wave at the guy. He waves back, and it's all virtually. It's not a real person. But the scary thing is that I actually have a little bit of fear of heights. I mean, not serious fear of heights, but when I'm on the edge of something like that, my body feels it. I feel fear. I can't control it. It's a natural reaction of my body. I walked to the edge, I looked out that door of that airplane, looking at the world below, the fact that I was flying through the air and I was on the edge of a door of a plane flying several hundred kilometers per hour through the space. My body felt like it was real. I started to panic. Seriously, I actually suffered panic in that moment, even though my head tells me, no, this is not a real world. All my other senses besides my head tell me, no, you are you're in a very dangerous situation here, Kirk. Okay, so virtual realities can be pretty serious because all those other sensors in our body are reacting. Okay, so we're both generating data and collecting data in that real world. So fortunately, my friend recognized that I was getting a little hyperventilating there. So he said, "Okay, let's back off from the door now." I mean, it was just sort of I felt dumb, like why I know it's not a real world, but my body, again, you're everything else about you says no. This is something to be afraid about. So, but anyway, so we have all these experiences like that we can have in virtual worlds. They're being used a lot in design. One I really love is virtual data exploration. Actually, you can walk through your data space. We actually had this at NASA 20 years ago. They called them caves. They were the virtual environments. I don't remember what it was. A compact augmented virtual environment. I don't remember what CAVE the acronym stood for, but the last three, VE, virtual environment. The CAVE was a virtual environment to explore your data. You can touch your data. You can move around the different dimensions of your data. Awesome. Hey, what's this surprising, unexpected trend over here? What's this correlation? What's this group? What's this cluster? Okay. What's this link? What's this association? I can start doing pattern discovery for real, walking through my data world. And course number 7, the metaverse. Oh my gosh, that's everywhere in conversation this year. So now we get to the closing here. We're getting close here to the end, and we have what we have here: the Internet of Things. So the Internet are sensors and devices everywhere. We're putting them in our homes, in our cars, in our cities, on our roads, and our machines. on our products that we mail, health wearable devices on our hands and arms, where we have heart monitors or heart rate monitors. We have connected cars. We have connected products. It's used in the industry everywhere. We call it the industrial Internet of Things, or the Industry 4.0. And even in climate monitoring, sensors monitoring how we're using energy, how we're producing carbon, how everything is going on. So Internet of Things is sensors everywhere, streaming data, which give actionable insights at the edge. I call it at the edge. That is at the point of data collection. So if you scroll back through these slides, which I won't do, you'll see on pretty much every one of the last 6 or 7 slides where I showed these applications, every single one of them talked about edge data. I didn't point that out, but I'm going to say it now. So edge data is basically, or edge intelligence, is intelligence at the point of data collection. And that's different from some traditional, for example, data analysis. I was 20 years out of grad school doing only astrophysics. I've done less astrophysics in recent years. I've done almost entirely machine learning, AI, in the last 20 years. But that data analysis was offline, right? We go to a telescope, collect the data. Or I work with the Hubble Space Telescope, which is in space, right? I mean, I didn't travel to the Hubble telescope. It's up there somewhere. Right? The data is sent down. It goes into a storage device. And over the period of the next few months, sometimes years, we take the data, we analyze it, we try to find interesting scientific discoveries and patterns and write research papers. And that's very offline, very offline. An edge detector is something that at the moment of data collection, or at the time of data collection, you take an action or decide not to take an action. But anyway, there's something that has to happen. So a recommender engine is an example, right? So I buy something online, I'm checking out on my e-commerce website, and it makes a product recommendation to me. Hey, Kirk, would you like to buy this? Other people like this. Well, it makes no sense to give me that recommendation 3 months from now. I'm checking out right now. Okay. And same thing with those virtual worlds. Okay. If I flip a switch and want to open a door, turn on a light, or do something in my virtual world, I don't want it to happen 3 months from now. It has to happen right now. Same thing with this autonomous vehicle, right? Right now. I mean, there's a person walking in front of your car. Oh, let's send the data back to the cloud and analyze it. And then 20 minutes from now, that the cloud says, oh, you need to put on the brakes and stop your car. Well, that's too late. The person was in front of my car alive 20 minutes ago. Sorry. So everything is, so we're moving to this dynamic world where if we're really going to have AI, that is this actionable, augmented, assisted, accelerated intelligence, it's got to be in the same way that we are. It's collecting image, sound, and context understanding at the moment of data collection. And that's edge data. That's edge intelligence. And IoT is providing that. It's putting these sensors at the edge that informing business, informing cities, informing homes, informing ourselves how to take the best actions. So I like to say that the internet used to be a thing. Now, with data collectors everywhere, things are the internet. And so what does that mean? I like to call it the internet of context. So the internet of things to me is the internet of context, because it's giving us all that other data about our data. Remember what I said about context. It's other data about our data. It's other information at the same time, in the same location, and in the same part of feature space as our data. So we're getting that context. We're getting that context understanding, that number 3 in that list of things I said: image understanding, language understanding, context understanding. So I don't think this scene was in the Toy Story movie, but I like to think it was. Context everywhere. Context to infinity and beyond. Okay, so Internet of Things gives us that. So being more serious about it, there's all these studies that show that the Internet of Things industry, including industrial Internet of Things, is going to be in the trillions of dollars. And just edge computing alone, that is edge intelligence, is going to be nearly $1 trillion, if not more than $1 trillion. This is enormous change in the emerging technologies of our world. Those edge intelligences apply to all of the things I just showed you. All those drones and autonomous vehicles and AR and VR, everything I showed you is going to be happening at the edge intelligence, those emerging technologies, that rapidly expanding frontier of emerging technologies. So this is big deal. And I really love this quote from an article at the bottom of the slide here. It says, Internet of Things companies will dominate the 2020s. Is your resume ready? Is your resume ready? Think about that. So this is where the action is. This is where all the action is. And I mean actionable insights, maximum actionable insights coming here. All right. So wrapping up, final remarks. Remember, the real A's of AI are not artificial. Okay, they are. If anything else, remember this. The real A's of AI are accelerated, actionable, assisted, augmented, adaptable, amplified, automated. Yes, and they're all very awesome. There are limitless opportunities. Here's an article here which just summarizes some of the things I said and other things, but there are limitless opportunities. So no matter what, I'll say that again, no matter what you're interested in, sports, entertainment, science, math, commerce, farming, doesn't matter, retail, you want to open up a coffee shop, there's data everywhere. All right. Customer data, machine data, network logs, sentiment data, every kind of data, facial recognition, speaker recognition, context understanding. Yes, of course, everywhere, limitless possibilities. And one of those places that is most applicable, I would say, is in our climate change and global sustainability initiatives. And I really love this concept from the United Nations. And all the nations of the world got together and created these sustainable development goals. Okay, there's 17 sustainable development goals. So no poverty, zero hunger, good health, quality education, gender equality, so on. I mean, just look at the list here. Just these 17 things we can all agree are great goals for our world. But if you just stop with 17 goals, oh, that's real nice. How do I do it? Right? How do I do it? How do I do anything to accomplish these goals? Well, they thought about that. So they put together what they call a metric. Okay, I call them KPIs. Okay, so that's a business term. Key performance indicators are things you measure in your business, right? Like how much revenue, how much profit, how many customers, how many sales. Those are key performance indicators. So the SDGs, these 17 sustainable development goals, actually have metrics underneath them. And there's over 230 that have been generated, which are metrics, things you can measure your performance towards achieving these goals. For example, let's say you have a business and you say, my goal is to end world hunger. Oh, great. How are you doing? Oh, I don't know. We're just trying to end world hunger. Well, what are you doing? Well, we're just trying to end world. No, we have metrics. We created this many new farms, sustainable farms. We gave jobs to this many people in rural communities. We've done this, we've done that. Okay, so you have metrics, you have performance metrics. So there's 230 KPIs. And what is that? That's data, right? A metric is data. All right, so we could use data for good and AI for good. Merge together all of our data, our AI, our Internet of Things, which are sensors on the world. I call it knowing the knowable, knowing the things that are knowable. We put sensors on things and we start knowing things that we can know. We collect the data from cities, persons, climate, environment, everything. And we start applying these pattern discovery techniques from machine learning, the class discovery, the correlation discovery, the anomaly and surprise discovery, the association discovery, and apply data science to say, what are the actions we can take to improve these outcomes? We collect the data, say, how are we doing? What can we do to do better? All of this stuff is possible for you when you put all these things together that we've talked about today. So I think this guy who lived over 500 years ago, Leonardo da Vinci, said it the best. Learn how to see and realize that everything connects to everything else. He must have been a graph scientist, right? He must have been a network scientist. Remember talk about link discovery, link analysis, network science. Go back to my slide on the 4 types of insights discovery. The one at the bottom I said was the most important because the natural data structure of the world is not rows and columns. It's a graph because everything connects to everything else. What you do impacts everything else. What you choose to do, what actions you take, we can measure it and measure how well it's going towards good goals, the goals that we set for our personal lives and the goals we set for our community and the goals you set for the whole world. You can do that. So thank you. I say come for the data, stay for the science. Just a couple of closing comments now. There's a book image there. I just put that up there because my first book, I'm a co-author on this book. It comes out at the end of this month. So, oh my gosh, we started working on this over 2 years ago, 3 years ago. It's finally coming out, Demystifying AI for the Enterprise. And then this quote, I love this quote, Isaac Asimov, famous science writer. He said, the most exciting phrase to hear in science, the phrase that heralds new discoveries, is not eureka, but that's funny. And I can attest to that because all my years in astronomy and my grad students, especially those from India, we were doing surprise discovery. That is finding the thing that was funny, that was not right in our data, because that's where the greatest discovery happens. So I'm wishing you many funny encounters with your data. Thank you very much.
Thanks a lot, sir. Thanks a lot. I guess I should tell the audience that the AI hype is real, as we can see. So let's get up for this revolutionary thing together. And
Well, I hope there's more reality than hype here. So.
definitely, sir. I I think there is some time for Q&A. Do you
Okay.
mind, sir? Yeah.
Yes, that's fine. Yes, go
Okay.
ahead.
Okay. So we have some questions. First is data science all about organizing and managing data for AI to work on, or is there more to data science that we are currently doing? Yeah.
Well, data science itself is as I said, a scientific process. And specifically, it's the scientific method applied to discovery from data. So in order to do that, yes, we have to organize data, manage data, clean data. So there's a data management component to data science. But
Right.
just like in any kind of science, there's a data management component, right? So as an astrophysicist, I had to manage my data, organize it, sort it, clean it, analyze it. So in any science, there's a process of data management, data sorting, data organization. But data science is more than that. Again, it's the scientific process of discovery, insights discovery, and I listed the 4 types of insights discovery, pattern discovery from data, and it's a scientific process because sometimes the pattern you find is not meaningful. It doesn't lead to anything, a useful decision. Let's say you're going to try to diagnose cancer from a medical image, right? How do you distinguish a cancer from a bruise or from an inflammation or from a scar? Maybe you have scar tissue because you had some previous operation. So you need to find the pattern that's most predictive of cancer if you're trying to identify cancer. So that's a scientific process. Okay, so the algorithms of machine learning, that's the math. Data science is the process. And during all that process, yes, we have to manage and organize data. I'll just say very briefly, my first really big project with neural networks and deep learning was actually almost 20 years ago. We were analyzing satellite images for NASA to identify wildfires across the world in remote regions of the world, to identify where fires were happening in remote regions from satellite images. And it was a 2 year project, and we probably spent 90% of 2 years just organizing the data. We actually got to do the neural network. We actually got to do the fun stuff in the last month of the project. All the rest of the time was just trying to figure out how to organize the data, put it in the right formats, how to feed it into the algorithms. But then we actually got to do building and testing and building out the models, testing the models, and building an accurate model. All that fun stuff happened at the end. So there's a lot of data organization that goes into the process, the scientific process of data science. So that's a long answer to your question, but hopefully it helps you to remember what all these things do with one another.
Yeah, I guess it's rightly said that if you give me 10 hours on a machine learning project, I'll spend the first 8 playing with the data.
Yeah. Well, you know what they say? Data scientists spend 80% of their time cleaning
Right.
and preparing data, and they spend the other 20% of their time complaining about cleaning and preparing data.
Absolutely.
It's not that bad, people. I'm just kidding. Maybe I'm not kidding.
Okay, so there's one more. Since you have been part of both research and industry, what lies at the intersection between both, and how do I find which one is for me? Yeah.
Well, that one, yeah, it comes down to personal passion, right? What do you feel most like you want to do? All right. So my background is astrophysics. I always wanted to be an astrophysics researcher at university, but when I got out of school, the job that opened up was related with NASA. Okay, so NASA is a government agency, but they do astrophysics, right? So it was with the Hubble Space Telescope. So that's great. I went and did that. I had this thing with the government for 20 years. And then I got this passion to teach people data science because after 20 years of seeing all the data, So I said, let's go teach it. So I went to the university, right? So now I was in an academic setting doing the thing that I really cared about. And then I realized that this data science is more than just astrophysics. It has to do with every business, every industry, everything in the world.
Right.
And I felt like I could apply that in all kinds of different interesting roles and applications. And if I went to consulting, so even though my lifelong dream was to be a university professor, I actually left it. I left being a university professor because I had the joy and pleasure of bringing applications of data science and AI to all kinds of different organizations and opportunities when I worked at a global consulting firm. And then I left that firm 8 months ago, and I'm part of an AI startup. Oh my gosh. I'm not even being paid a real salary because we're just a startup, right? Okay. So who knew that I would just give up almost all my salary to go do some fun project? But it's changing the world. It's changing talent acquisition. It's changing. And so what the common thread through I think my wife said to me this. She said, you had many different careers. She was really surprised. Oh, you've had so many careers. And I said, no, I've only had one career as a scientist.
Scientist.
I've had many different jobs. And so think about what your career is, not what your job is. And so whether you're in industry or academia or at a startup or government or whatever you're doing, consider that just a step in your career. There are many steps in your career. That's the thing. There are many, many, many steps in the career. So think about the big picture of what you care about. It's like those sustainability goals, right? I mean, what is the big goal I want? But I had to do a lot of different things to get there, and that's okay because that's normal life. That's life. So you can have many different kinds of jobs and still have the same career, or you can change careers, right? I mean,
Yeah.
this music group, the music group Queen, right? I mean, one of the chief performers on Queen is an astrophysicist, right? I mean,
Right.
he publishes research papers on astrophysics. You take a look at the guy, you might not think he's a typical astrophysicist, but I've known some pretty interesting. I've known some pretty interesting astrophysicists, so he fits right in.
Now we all know one.
Now you all know one.
Yeah. So I'll take just one last question. So one major issue with AI is that it requires a large amount of data to be fed to the model. But then that arises the data privacy issues. How do companies take care of this while ensuring user privacy and end-to-end encryption?
Yeah, that's a huge research field. Okay, so how many days or hours do I have to answer this question?
We can
No,
just, yeah.
no. Well, I like to. My short answer to this question, of course, is you have to monitor who's using the data and making sure that they're using it correctly and properly. But also, you need to anonymize the data. That is, de-identify anything that's personable, identifiable information. So that's what we want to do. But how do you do that? So I like to say that we can use AI for AI. That is, we can use AI to help identify misuses. Look at the patterns of use of the data. Look at the patterns in the data, and see, are the data being misused? Are there privacy violations taking place? Are there things in the data that shouldn't be accessible? It can identify things in the data. And I actually know I'm working with a company now who's actually doing this. Their whole business is to do de-identification and to prove it. They're building a validator to prove that I can't figure out who this person is. All right. So use AI and data science on the data you're using in the data science. Am I making sense? Use AI to make AI.
Yeah. Hmm.
All right. So AI is watching the AI. All right. That's a better way to say it. The AI has its eye on AI.
All right, sir. All right. So to end this, I'll finally say some things. Kirk, thank you so much for joining with us tonight. Given your interdisciplinary experience and knowledge, I'm sure this could go on for 3-4 hours. But I'm sure our audience is taking back a great deal of learning with them. I personally enjoyed it a lot. Thank you everyone for being a wonderful audience and for all the thought-provoking questions. If you have any final thoughts about Amalthea, about our college, about this webinar, Kirk, we'd be delighted to hear.
Great. Thank you.
Yes, sir. So if you have any final thoughts.
No, this is good. Great. Thank you for hosting this. Thank you for the opportunity. I almost lost my breath. No, it was,
Yeah.
yeah, great questions. I wish I didn't tell you the rest of the story. When I went to Bangalore and I gave
Yes,
that
sir,
talk,
we can continue.
I gave that talk. I gave the keynote talk, the first talk of the first morning of the Data Hack Summit. And when I finished my talk, all these people came up to me to talk to me because I have a lot of Twitter followers in India. A lot of my Twitter followers are in India, and a lot of people already knew me. And so they started asking me questions. And so the organizer said, "Hey, can you go take these questions out into the lobby?" So we go out into the lobby to talk, and all these people follow me out there. And I'm standing out there for, I think, 8.5 hours.
Oh my goodness.
Okay, my talk was 9 o'clock to 10 o'clock. From 10 o'clock in the morning to 6:30 in the evening, I was still standing on the stairs in the lobby talking to all these people.
Amazing. Yeah,
And
that's how the
so
craze is for this field.
I loved it. I was exhausted. I loved it. But the guy who was my host, like you're my host today, he came to me about at 6:30 and he said, Dr. Kirk, we have someone in the speaker room who really wants to talk with you. There's, you have an important meeting. And so he was able to extract me from the crowds of people. And I get to the speaker room, the back room here, like the lounge here, speaker lounge. And I said, well, who is it? What is it? He said, oh, it's nobody. I just wanted you to sit down and rest. So that's where I sat down and rested on the couch. And I was like, my eyes were half open. And that's when everybody came out from the organizing committee of the conference and brought the little birthday cake and sang happy birthday to me.
Great to hear that, sir. Amazing.
That was a great day. That was a great day. I'll never forget that day. That was a great day.
Thank you for sharing that, sir. Thank you. Yeah.
Anyway, so I'm signing off.
All right.
Okay.
Thank you so much. Yeah.
Well, thank you too. This has been fabulous. I'll send my thanks also to email to everyone. I appreciated this opportunity very much. Thank you.
Great. Thank you so much.
All right.